Hello, my name is Chris Murphy, and in this video, you're going to learn how to name carboxylic acid anhydrides. Before jumping into naming carboxylic acid anhydrides, it would be first good to make sure you're comfortable naming carboxylic acids. Anhydride nomenclature is going to be very similar to carboxylic acid nomenclature, and if you have the carboxylic acids down, these are going to be easy. When it comes to our anhydrides, you might encounter a few different categories. Some might be symmetrical. Symmetrical anhydrides just mean that they're going to be the same on either side of the oxygen in the middle. Here's an example where we have the same number of carbons on either side. So to name this, think about these anhydrides as if they are carboxylic acids smushed together into one molecule. We can break it apart and think about their corresponding carboxylic acids. Each of these have 3 carbons, so they're both called propanoic acid. So to name the original anhydride, all you need to do is replace the acid with anhydride. So instead of propanoic acid, we're going to have propanoic anhydride. Now when you're faced with an asymmetrical carboxylic acid anhydride, it's going to be very similar. We still want to think about breaking the anhydride apart into its 2 corresponding carboxylic acids. For example, we have 3 carbons on the left and 4 carbons on the right. So if we break this apart into carboxylic acids, just name them separately. The carboxylic acid on the left is going to be propanoic acid, since it has a 3-carbon chain. And the carboxylic on the right is going to be butanoic acid with its 4-carbon chain. Now to name the original anhydride, we're going to have to take those carboxylic acid names and put them in alphabetical order. So we're going to have the butanoic acid and propanoic acid. And then the last thing you're going to do is plug in the word anhydride in place of acid. So if we put these in alphabetical order, take out acid, put in anhydride, the whole molecule is going to be called butanoic, propanoic anhydride. The last category of anhydrides are the cyclic ones. These things make rings. Here's an example. And to name these, it's again going to be a lot like naming a carboxylic acid. So let's think about breaking apart this ring into 2 corresponding carboxylic acid functional groups. Name it as a carboxylic acid, just like we've done before. This is going to be 1, 2, 3, 4, 5 carbons. So this is going to be a pentane dioic acid. And like you've already seen, let's cut out the word acid, replace it with anhydride. So we're left with pentane dioic anhydride. Now for you to get some practice. Molecule A, it's symmetrical. So like you've seen before, let's break it apart into its 2 corresponding carboxylic acid. Here's the guy on the left, here's the guy on the right. Looks like they're going to be 4-carbon chains, so we got butanoic acid for each of them, which means it's going to be butanoic anhydride. Now to make it a little bit more difficult, here's an asymmetric anhydride, but the concept still applies. We're going to break this apart into 2 carboxylic acids. Name them separately. So this group right here is going to be on carbon 3, and it's a 3-methyl. Again, we're going to start the chain with number 1 on the carboxylic acid functional group. And it's 4 carbons long, so this is a 3-methyl butanoic acid. The carboxylic acid on the right side is a 3-carbon chain, so this is going to be propanoic acid. Now to go back to the original anhydride, we put those names in alphabetical order. So M in methyl comes before P in the propanoic. So this will be 3-methyl butanoic propanoic anhydride. Molecule C, we got a cyclic anhydride. Again, let's think about breaking this apart into 2 carboxylic acid functional groups. Then we can name it as a carboxylic acid. This one's going to have 1, 2, 3, 4 carbons. So this is a butane dioic acid, which means the anhydride would be butane dioic anhydride. And lastly, molecule D, fairly intimidating, but the same concept applies. We're going to break it apart into its 2 carboxylic acid functional groups, name it as a carboxylic acid first. So I'm going to name this one with 1 here, because that gives our alkene the lower number of 2. We have a substituent over here on carbon 4. All right, let's put the pieces together. So this is going to be isopropyl. And then we're going to have a carbon 2, with an alkene group, and it's 5 carbons. So it's 4-isopropyl 2-pentene dioic acid. That's the hard work. Now all you have to do is chop off the word acid and replace it with anhydride to get the original anhydride's name. So the overall name is going to be 4-isopropyl 2-pentene dioic anhydride.